So we got a bit of snow and the solar panels are very well covered. They're giving no power and the battery pack or battery bank is at 12.52 volts. But then if you take the voltage of the solar panels themselves, they're actually at like almost 13.9 volts. That's over a volt higher than the batteries. So you would think that would charge, but this was a very reasonably priced MPPT charge controller. So I'm thinking that it doesn't have the functionality of a more expensive model. But I'm fine with that. Seems to work fine whenever the voltage is higher, so that's good enough. It's just good to be mindful of those limitations. This is probably going to be the last snow of the season, so probably won't have to deal with snow for another like year or so. This was kind of unexpected because we were having an early spring. 1.12 amps or 14 watts, and the voltage is climbing up to 13 volts. So let's let this charge for a little bit, and then we can do what I think would be a good benchmark. So yesterday I charged my electric bicycle off this battery bank for 30 minutes, and it pulled the voltage down to 12.04 volts. I figure if I keep doing that, trying that every single day, then eventually it might have, like maybe it doesn't get pulled down as low or something like that. Like as these batteries kind of get a little bit more revived or fully charged. Not sure though. Could really depend on too many factors. Like right now it's pretty cold, so it could just be that it would be at a lower voltage anyway because these are kind of frozen. Sun has gone down for this day and it's no longer providing power to the batteries. Battery voltage 12.78. That, or 12.77. That's pretty good. So let's turn this on. And I'll set a timer for 30 minutes and we'll come back. And this is probably taking, I think, like 120 watts of power. Yeah. It's been 30 minutes and the battery's gone down to 11.9 volts under load. Let's turn that off. Now I've waited 5 minutes and the voltage has drifted back up to 12.30 volts without any load. I'm actually kind of happy with that because I did get 3 more miles worth of electricity into my e-bike battery, so that's not too bad. Let's let this sit for a couple days to recharge as much as it can, and then we can do this test again. So the battery back's been charging for 2 days now, and it's at 12.77 volts after a nice day of charging. It's been about 40 minutes or so since the sun went down. Let's turn on the charger. And I'll set a timer for 30 minutes, then we'll come back out. And it's actually even colder tonight than it was yesterday, as you can see from my breath. So it's been 30 minutes and the battery's gone down to 11.99 volts. That's better than last time. Holy cow. Well, as with last time, we'll turn off the charger, wait 5 minutes, and see where the voltage goes back up to. Holy hell. 12.41 volts. That's not bad for being frozen. Well, I'm curious to see if there's any more improvement over the next 2 days. So I guess we'll try this again the day after tomorrow. It's been yet another couple days. Battery pack's at 12.73 volts. I say let's let the bike charge for 30 more minutes and see what happens. The weather right now is actually nice and warm. About 60 degrees Fahrenheit. The weather spiked up a lot in the past couple days. It has been 30 minutes. The voltage is down to 12.08 volts. That is actually pretty surprising. Set a timer for 5 minutes, and I've actually found a good song for a timer tune, like the alert sound. It's the Nintendo Land Retro Main Plaza theme. That one. It's actually pretty good. It's a very nice notification sound. You guys might want to start using that for your notifications too. At least for things like this, for like timers for cooking and whatnot. So 12.45 volts. That is not bad. I'm happy with that. And I consider that pretty much it for the experiments for this week's Solar Sunday. I don't know if I'm going to have a Solar Sunday next weekend. I might just kind of let these sit for a little bit and kind of wait. But I think next thing I'm probably going to do is I want to run a wire to my house and have an old 1930s voltmeter wired up to the solar panels so I can check the voltage of the solar panels without having to come outside, because if there's something blocking the solar panels like a bunch of leaves or snow or something like that, the solar panel voltage will obviously be really low. Back to this though, I am really happy with this. So yeah, I think that's pretty much it for this video. I'm kind of bored of this test, and I think it wouldn't probably fit too well in any other videos, but it still is kind of interesting, maybe? I don't know. Kind of happy with that. Plus, over this experiment, I figure every 30 minutes of charge, if I get a roughly 6 miles of charge per hour of charging, then that should be like 3 hours per session. I've done it 4 times, so I should have 12 more miles of power put into my battery pack, my electric bicycle battery pack, from solar power. It'd be kind of cool to have this entire bike always run off solar power in the future. Like, no plugging into the grid at all. That'd be kind of neat. I could get behind that. Definitely. Well, I hope you guys enjoyed this video, and thank you very much for watching. See ya!